if it's a difference of two squares problem, there's always going to be something squared and then something squared. Or it could be something to the fourth and something to the fourth, because that is technically something squared. It can't just be like 5x minus 16, because the x is not squared. Okay, so when you're thinking of that, you're thinking of two terms, and they have to be squares. Or at least we have to be able to make them into squares. Okay, so look at the examples underneath there. You see how all of the examples underneath there are two terms? Okay, now just because it's two terms doesn't mean that it's necessarily the difference of two squares. It could be factoring by greatest common factor or something like that. But if it's three terms, definitely not this. Okay. Your answer when you work out a difference of two squares problem, it's always two parentheses and one has a plus and one has a minus. Let me give you an example. If we have x squared minus y squared, which is just sort of like the example problem, then your answer is x plus y and x minus y every single time. Now, if you don't see it, you could multiply it out and realize that the plus and the minus cancel out those middle terms to make that be a 0. And so that's why it works. Okay? Basically what happens is you take the square root of x and you take the square root of y. Square root means find whatever it is that multiplies twice to give you that number. Okay? The square root of 4 is 2. The square root of 16 is 4. Square root of 30, I don't know. You understand? Okay. So let's look at the first problem. So we have x squared minus 9. Is it the difference? The difference means a minus. Is it a difference? Yes. Is that something squared? Is x squared something squared? Yes. Is 9 something squared? What is it? 3. Good. Okay, so here's what we do. You write the two parentheses, x and x, because x times x is x squared. 3 and 3, because 3 times 3 is 9. One's a plus and one's a minus, and that's it. Okay, let's go down to, well, we'll just keep going across. 4x squared minus 64. I will tell you that this one's just a little bit trickier. Technically, 4x squared and 64 are all squares. Okay? However, there is a greatest common factor. What number goes into both 4 and 64? 2 does, but also 4. If you don't factor out the greatest common factor first, you actually have to factor it out at the end. So on these problems, you look to figure out, is there a greatest common factor? You might have to factor it first, and then do the difference of two squares. So we're going to divide by 4, because 4 is the greatest common factor. And you get 4 times x squared minus 64 divided by 4 is 16. Okay, and then now you just bring down that 4, and then you do difference of two squares with x squared minus 16. Okay, so what do I do with the x squared? Just make x's. What do I do with the 16? 4, because 4 times 4 is 16, and one's a plus and one's a minus. If you would have factored it at the beginning, you would have got 2x minus 8 and 2x plus 8, but then you'd have to take out the 2's on each of those, and that gets weird. Okay? Any questions? All right, let's look at the next one. 18x squared minus 50. Is there a number that goes into both 18 and 50? 2. So let's divide by 2. 18 divided by 2 is 9. 50 divided by 2 is 25. Okay, then I look at it. Am I done, or can I do difference of two squares? You can do difference of two squares. Okay, so here's my two parentheses. What's the square root of 9x squared? 3x and 3x. What's the square root of 25? So 5 and 5. One's a plus and one's a minus. Okay, last one. So it's x to the fourth minus y to the fourth. Is there a greatest common factor? Just one, so there's nothing to do there. Is it the difference of two squares? Yes, because it's a minus. And what can I multiply twice that will give me x to the fourth? X squared. Okay, so here's how you do this one. There's your parentheses, x squared and x squared, y squared and y squared, and then a plus and a minus. Unfortunately, you're not finished on this one because there's still another part of it that has another difference of two squares. Okay? You can't do anything with the first part. X squared plus y squared, you can't do anything with that because it's a sum. If you see the sum of two squares, you have to leave it. Nothing you can do. Alright, so then to finish, I can do the difference of two squares with this second part, which x squared minus y squared becomes x and x, y and y, and then plus and minus. So let's try these. I will tell you that there's a couple tricky ones on here, but I'm going to let you try it first. Hopefully the first one was pretty easy. It's just a simple one where you just do the root of each and do your two parentheses. So you have x and x. What times what is 36? 6. And then plus and minus. Questions on number 1? Okay, number 2. There's something you need to do first before you can do that. What is it that you need to do? Divide by 5. Factor out of 5. So if I divide everything by 5, I get x squared minus 4. Am I done? Do I leave it like that? Now I can do difference of two squares with the x squared minus 4. So you have x and x. What times what is 4? 2. And then a plus and a minus. Okay, next. Well, first of all, it's not a difference of two squares. How do I know? There's not a minus in the middle of it. It's a plus. So that's kind of tricky. So is there a greatest common factor? 10. So let's divide out the 10. That's the answer. You can't go any further. And it's because it's not a difference. Okay? I know that some people want to put like x plus 2 times x plus 2 instead. Because you think, well, it's plus, so as long as I have pluses everywhere, it should work. Well, if you multiply that out, you get x squared plus 4x plus 4. It doesn't cancel out that middle term, so there's nothing you can do there. You just leave it. That's called the sum of two squares, and you just have to leave it like that. There's nothing to do to it. Okay. All right, number 4, the only difference is that it's a difference. And so when you divide by 10, you get something similar, and then you just factor that second part of it into x minus 2, x plus 2. All right, last one. Is there a greatest common factor on the last one? Do they have x in common? So we can factor or divide by x, which would give me 25x squared minus 1. When you have a 1, you can still do this thing because 1 times 1 is 1. Okay? And so I leave the x and then make my parentheses. The square root of 25 is 5x. The square root of 1 is 1. And then plus and minus.